Question 9, part 2. We want to find the limit as x tends to 0 of x ln x. Now, in this question, we don't have a quotient, but we do have a product of two different functions, so x and ln x. So what we can do is take the function x, and it is clear to see that we can have x is equal to 1 over x, x to the minus 1. X to the minus 1, 1 over x, so it is just x. And if we substitute this in, that will give us the limit as x tends to 0 of ln x over x to the minus 1. So now we've got our quotient. Let's have a look at what happens as x tends to 0. So as x tends to 0, ln x, think of the graph for ln x, something like this. Should be like that. Tends to negative infinity, and 1 over x, that tends to infinity. So here we've got infinity over infinity, so we can use the L'Hopital's rule. So L'Hopital's rule, we can say that this is equal to the limit as x tends to 0. The derivative of ln x is 1 over x, and we can divide that by negative x to the negative 2. Neatening this up gives us x tends to 0 of negative x squared over x. And whilst we can't work out the limit here, because it would be 0 over 0, we can now use L'Hopital's rule again, and that should give us our limit. So the limit as x tends to 0, x squared goes to 2x, x goes to 1. So as as x tends to 0, 2x tends to 0. So the limit of x ln x as x tends to 0 is 0.